Now you're asking, how did I know to use a 3 before? It's just like here, I'm working with squared. Is there something times itself that would give me 36? So could I rewrite this as 6 squared x to the 10th then? And I still have this index of an implied 2, don't I? Right? So how many times will 2 go into 2? So I have a 6 on the outside of the radical. 2 will go into 10. How many times? Did I have anything left over inside the radical after dividing the exponents? Nope. Okay. So I have 6x to the 5th. Actually, the correct answer would have been plus or minus 6x to the 5th, because whenever I take square roots or even indexes, it's always plus or minus.
So all these should have been plus or minus?
Except the ones that started out with just a minus.
So if they're evens?
Only if they're evens. Okay, only if they're evens.
Cool.
So I have a negative the square root of y plus 7 in parentheses to the 16th power. What's the index? It's an implied 2, isn't it? So, since this whole y plus 7 is in parentheses, do I have to worry about anything inside the parentheses? No. So I'd take 2 into 16, so I'd have negative parentheses y plus 7 to the 8th power. Was there anything left over? Now, if you want to get real creative, you need to multiply this out 8 times. Which means take y plus 7 times y plus 7 times y plus 7 times y plus 7 times y plus 7. Huh?
No.
Negative 8y plus negative.
No, it'd be 7 times 7 times 7 times 7 times 7 times 7 times 5.
You make a y to the end.
764,801.
You would actually have 9 terms when you multiplied it out.
Wendy's got it. Oh, you just write it out 8 times?
You have to do the FOIL method 8 times.
I'm not doing that. Yeah, so it'd be like, y,
I'm not asking you to do that. I'm not asking you to do that, but that's what it should be done.
Okay, well, yeah, no.
Okay?
What if that y plus 7 wasn't parentheses?
Huh?
Like, y plus 7 wasn't parentheses.
What about it? I don't know what your question is yet.
If you didn't have the parentheses and the 16.
Yeah. Can we just do that?
No.
No?
No. Because would 2 go into either one of those because it's a binomial?
So you can't do it?
Nope.
That was my question.
No. Nope. It has to have a parentheses around the binomial. Okay? If there's a plus or a minus or anything like that in here, there has to be a parentheses around the whole thing to a power in order for it to work right. Okay?
So if you just add plus or minus, it doesn't really mean anything, it's just there because you're square rooting it?
Yeah. As long as that index is even. You can't do it with an odd index, it's only with an even index. Huh? Why is it, why if it's even?
No.
Because couldn't I take a negative 5 times a negative 5 and still end up with a positive 25 inside? Or a positive 5 and a positive 5? Okay? That's why. What? Y to the 8. 100 y to the 8. We got an even index again, don't we? Right, of 2?
Yep.
Can I rewrite 100 as something that's squared or has an even exponent or anything like that? I'd say I could. How about 10 squared?
No, want 8, square at 8.
Yes. So now can I take 2 into this 2? I get a 10. Right? Can I take 2 into this y to the 8? So 2 goes into the 8. 4? Right? Okay.
I don't really understand the second step. Like why you do the 10 squared minus because you want like this, like 10 times 10?
Yes.
Okay.
If you know that it's 10 times 10 and you're working with squared, that's fine. But whenever you start getting into like 4th and 5th roots and so forth like that, it makes it more difficult to find.
So you do it squared all the time? Okay, that makes sense.
No, it doesn't have to be squared all the time. No, it doesn't.
Were the two
We're going to change that from the 18th to the 20th. What is the simplest factors that I can find out of 64?
8.
But I'm working with a 6th root.
Oh, do.
I could take 2 times 2, which is 4, right? Times another 2, which is 8.
16.
Times another 2, which would give me 16.
32.
Times another 2, which is 32.
64.
Times another 2, which would be 64. Correct? So I could rewrite this as 2 to the 6th, 2y plus 1 to the 20th. Do you agree?
Okay, so 2 times 2 times 2 times 2 equals 8.
Yes. It does. So this 6 goes into this exponent of 6 how many times? So I'd have a 2 out here, wouldn't I? Right? This 6, now I'm going to take that into this whole set of parentheses, which means into this exponent. So 6 goes into 20 how many times?
3.
So that means out here I'd have 2y plus 1 to the 3rd. But inside, would I have anything left over? 2y plus 1 to the 2nd power. Okay? I'm going to change this problem just a little bit. I'm going to make this a 5th root. We're going to make this 128. And 2y plus 1 to the 17th. In working with your numbers, we already knew that 2 to the 6th was 64, would you agree? Well, what's 2 times 64? 128, isn't it? So could I rewrite the 128 as 2 to the 7th power? If 2 to the 6th was 64, isn't 128 then 2 to the 7th? And 2y plus 1 to the 17th power. Will 5 go into 7? So I'd have 2 to the 1, but inside of here, I would have 2 to the 2nd, wouldn't I? Will 5 go into 17? So I'd have 2y plus 1 to the 3rd power. And what would I have left over in here? I'd say 2nd. 5 goes into 17, 3 times 5 is 15, which leaves me with 2. Okay? If I really wanted to make this simplified, what's 2 squared? That would be my final answer. Okay?